Hello class, welcome to the lesson for today. We are still continuing on the new topic that we started, that's about binomial expansion of terms. In our last lesson, we had looked at what we mean by the term binomial. And we said that's a mathematical expression with two numbers. That's what the prefix bi stands for. Nomial stands for numbers. Expansion, we'll look at how you can expand that binomial term by a certain power. From power 0 up to power 4 was the main focus so that you can understand how it works out. We had a few examples here on the board to show how we can expand a binomial expression by power 0, 1, 2, 3, and eventually by power 4. In our lesson today, we're going to look at more of the binomial expansion, but how we can expand those binomial expressions. We are going to also introduce now the concept of Pascal's triangle, how we can figure it out ourselves, and also where we can refer to it, and then also have practical examples on how to work it out. So, beginning with what we already know about binomial expansion. We were looking at how you can expand an expression by power 0, by power 1, by power 2, by power 3, and power 4. That was the focus yesterday. And I'm going to have them here on the board, more of the same. And then we're going to note an interesting thing about what we call the coefficient that is attached to the various terms. So, for the expression a plus b raised to power 0, we did say that just like the laws of integers indicate, any number raised to power 0 is always equal to 1. For a plus b, a binomial expression raised to power 1, it will be a plus b. Again, as you know from the laws of indices, any term raised to power 1 is always equal to the same term. Nothing more, nothing less. Then we did look at a plus b power 2, and we said that this one is related to the quadratic expressions. How do we expand this term? It should be a power 2, that is a power 2. The symbol here is plus, so it should be a plus. Then 2 times a times b to give us 2ab, and then b squared. B squared. In our workout yesterday, the last lesson, we continued with that a power 3, and we did say that this one will be a power 3 plus 3 a squared b plus 3 a b squared plus b cubed. And then the last term that we did work out as an example was a plus b power 4. A plus b, the binomial expression raised to the power of 4, and we saw that this one would be a power 4 plus 4 a power 3b plus 6. As per the example here, plus 6 a squared b squared plus 4 ab cubed plus b power 4. We did mention also yesterday, previously in our last lesson, that when you are expanding these terms by a certain power, it's very clear from here. If this is positive, all the terms will be positive. But if this is negative, the first term will be positive, the second term will be negative, and the third will be positive. If you are raising it to power 3 and it is negative, the first term will be positive, the next will be negative, that will be positive, and that will be negative. If you are raising it to power 4 and it is negative, not plus, the first term will always be positive, the next will be negative, that will be positive, that will be negative, that will be positive. So if the binomial term has a negative sign, your result will be alternating from positive to negative, and on and on and on. But if it's just positive, all the terms are positive. Now, one thing that we also noted yesterday was this. Though we don't indicate it here, but the coefficient here should be 1. The coefficient here is 1, and this is 1. We always don't write the coefficient 1 if there's no other number. And the coefficient is the number that is just in front of an expression that is unknown, like that. Same here, the coefficient should be 1, and here 1, here 1, here 1, same here 1, as well as here 1. Now, we also did say in our previous lesson that if you are raising the binomial expression to power 3, this first term will be raised to power 3, according to what you have there. Then in the next one, it will reduce by 1, it becomes power 2. And then in the next one, it reduces, becomes power 1. So we don't indicate that there, but it should actually be 1. It's not a must to indicate that, but let's just write it there. Good. And then in the last one, it should be power 0, but any number is power 0 is 1, so we don't actually write it. The second term should be raised to power 0 in this first expression here, in first term, but we don't indicate because any number is power 0 is 1. Here, it should be raised to power 1. That's why we write it there. Here, it should be raised to power 2. And then there, it will be raised to power 3, which was the power by which we were expanding it. So, if you are expanding a binomial expression, what you notice is that the first term will be starting with the highest power possible, keeps on reducing until it is power 0 or disappears. The second term will keep on rising from power 0, which don't indicate, all the way to the highest power that we have, in this case is power 3. You can see the same in power 4. When you come to power 4, the first term, in the first term here it is power 4. In the second term it's power 3, it reduces by 1. In the third term it's power 2, reduces by 1. In the fourth term it's power 1. And then here should be power 0, so we don't even write it. While the second term should be, in the first term here, it should be power 0, so we don't write it because it's 1. Second term it's power 1, that's why it is there as B. You don't have to write power 1, but it's power 1. In the next one, it will be power 2, it is increasing by 1. In the next one, it is power 3, increasing by 1. And in the last one, it is power 4, which was the power that you are expanding the binomial expression. I hope we note that kind of pattern. Now, the next question that comes is the coefficient. How do you know which coefficient is supposed to be where? Now, in this first one, when you raise a term to power 0, what you get is just 1. But here, if you raise it to power 1, you get 2 terms, and the coefficient in both cases is 1. When you are raising binomial expression to power 2, the coefficients you're going to get are 1, 2, and 1. If you raise it to power 3, the coefficients that you're going to get are 1, 3, 3, and 1. If you raise it to power 4, the coefficients you're going to get are 1, 4, 6, 4, and 1. This is a very good observation to be making here. Raised to power 0, there is only one coefficient, that is 1. Raised to power 1, there are 2 coefficients and both of them are 1. Raised to power 2, there are 3 coefficients and that is 1, 2, and 1. So if you're raising power 2, there are 3 coefficients. Raised to power 1, there are 2 coefficients. Raised to power 0, there is 1 coefficient. Raised to power 3, there are 4 coefficients. This, and that. Raised to power 4, there are 5 coefficients. 1, 4, 6, 4, and 1. So you can see again another pattern. If you're raising to a particular power, the number of coefficients will be that power plus 1. It is increasing by 1. Now, this kind of pattern was discovered by one of the most famous mathematicians or physicists that existed, and that was called Pascal. Eventually, Pascal ended up coming with what we call a Pascal's triangle to help identify the coefficients that are here. And that's what you're going to form right now. Pascal's triangle. How is Pascal's triangle supposed to be made? So, in our second part of this lesson, we are going to show how to make Pascal's triangle here on the board, which is very similar to what we have here. These numbers will be familiar to you when you make the Pascal's triangle. And then we are going to actually answer questions, and using Pascal's triangle, we'll be able to answer them very easily without necessarily expanding it in a long way like we did in our previous lesson. So see you in the second part.